Today we will give a quick talk on models and database. This presentation was dedicated to Zhuai Huoliu and the Ecological group members at Tsinghua University, and also to Professor Jake Zhengzhong at Beijing Normal University. When we look deep into nature, creatures, many interesting and universal patterns will be found, like fractal, hierarchy, network, wave, etc. The mathematical language is naturally connected with nature. Modeling helps us to interpret the behavior of nature and deal with the relationship between human and nature. In this presentation, I will introduce the four main types of models we categorized and introduce some useful links of the public database for microscopic Earth observation. The whole presentation, including the Chinese introduction and vocabulary, is available at my research page sharing. Then you can look into details. Why is it essential to categorize and provide a framework for modeling? Because we want to match them correctly with the corresponding usage, to name them precisely, at the same time to forget created terms, to know the fundamental connection breaking the borders to have more mobility when using them, to memorize how they develop and to develop them systematically in a merged way, to adapt the new tech, like machine learning. The four main types of the modeling are 1. Dynamic and complexity, 2. Statistic, big data applied with machine learning, 3. Network analysis and operations research, 4. Geo-subjects and space-time models. They are based on the different mathematical branches. As you have very basic college math base, you can access to all these methods. In this presentation, each model will be quickly introduced with their key concepts. It's suggested to look into details on their application with the online shared slides and the references. The first is the dynamic model or system dynamics. It was abstracted from the flowing water, following the principles of kinetics. The key components of the model include stock variable, flow variable, and parameters. The flow rate is determined by the stock amount in the parameters. The process was determined by the status of the last moment while deciding the status in the next moment. This is the key assumption of this kind of modeling. The dynamic model generated the four most basic growing behaviors: linear, exponential, goal-seeking, and waving fluctuation. The most recommended book is The Limits to Growth, written by the Club of Rome, and another response after over 40 years, named Flourishing Within Limits to Growth, following Nature's Way, released by the Club of Siena. Both they discuss the long-term human phase of the sustainability using system dynamic approach. You can mark it on Goodreads website and friend me at Joey. From here we are transitioning to the complexity models from the dynamical systems. Remembering the population growth equation and the S-curve is growth within limits, or we called logistic growth. When we adjusted the parameter R, the intrinsic growth rate, from 3 to above, the curve from the periodical fluctuation caused by the overshooting to the chaos, becoming unpredictable and initial value sensitive. When the scale changed, the system became complex. It's suggested to watch the 2 classical documentaries about fractals and chaos. We can apply with the time series data to the phase space reconstruction method to detect the causality in the coupled ecosystem based on the chaos theory. The complexity science has inspired many modern disciplinary. The second type is statistical models. We need to understand the essence of the statistical analysis processes to decrease the entropy or the disorderliness of the information we receive them to extract the key features. In general, there are descriptive and analytical ones. And when we want to see the whole samples more than the partial population, containing the high volume and streaming data, big data comes. We need machine learning to dig up the value of this huge digital information. In my view, machine learning means the advanced multivariable statistics adding the signal processing. It is a kind of digital text rooted from the complexity science. The two major algorithms of machine learning, or the deep learning, are CNN and RNN, used to deal with the imagery data and the time series data like voice and signals respectively. The convolutional neural network, CNN, used convolution and pooling to extract the partial and global features of the pixelated information and project the deepened feature layer to the fully connected layers to learn the data. The long short-term memory in the hidden layer of the recurrent neural network, RNN, was developed with the forget gate designed to deal with the continuous long time series information. The milestone of AlphaGo's competing over the human Go game player demonstrated the strength of the simple model to deal with the complex system using big data. It's been widely realized that we have to adapt to the artificial intelligence systems in the era of big data. The relationship is the key topics of eco and environmental studies. Ecological network, social network, and flow network have the independent term and metric systems, but are connected regarding their fundamental principles with input-output structure. I have no experience in the operations research myself, but it has broad applications. Here I just showed it very shortly. The thriving internet activities taught us to think with an internet mind. The application of network analysis applying linear algebra is tremendous in the recent decades, developing into a newly emerging subject named network science around the world. For the fourth type, geomodels, simply saying, just to map and visualize everything with the computer for our Earth. Here, seen from the origin of the words, we could understand its connection to geometry and geography. So trying to apply the same multi-dimensional thinking to learn and use that kind of knowledge. When the geographical object's moving in a dynamic way, as in the time dimension, we have space-time model. This kind of modeling has some properties. First, relativeness. It is basic to know that usually the eco or the environmental subjects have three dimensions: space, time, and relation. Second, integrity as energy, material, and information, 3 in 1. Look at this illustration for the species growth and distribution under the environmental factors. We can understand the peak as the optimized condition in the saddle surface in this model. The third property is bidirectionality in the distribution or selection under environmental pressure. The fourth is the periodicity, that is the periodic fluctuation of the phenological events was basically caused by the circular motion of the Earth's rotation and revolution. The fifth is the directionality, which is seen at the whole and regarding the system as self-adaptive. The model of Panarchy gave a generalized trajectory of the system collapse and restoration. The sixth is the synchronicity, or stated as high spatial correlation, and non-synchronicity, which was discovered and preliminarily explained in my PhD research. Simply saying, taking the grassland as the example, where the better vegetation, where's the better hydro condition, higher vapor. But when the vegetation became better, the hydro condition did not necessarily change simultaneously or immediately. This is a common but easily overlooked phenomenon in the structure function of the systems. The synchronicity of space-time is related to the system's structure as we found. Here is a quick review about what today I talked. Sorry for another metaphor I didn't mention in the front about the statistical, the fire sparkles. It means the randomness. You can understand that being opposite to the certainty of the flowing waters for the dynamic models. All the models are not absolutely independent, rather interrelated with each other in a developing process. Scale matters in the transition. Here is the key terms table with English and Chinese. It is also the keywords of my research line in the recent years. Finally, I list some most frequently used databases released by the US, China, and European agencies that for the environmental monitoring and analysis. Some useful references cited as the classical readings, cases, and learning materials. In the epilogue, I would like to share some thinking on the research paradigm. It showed the two directions from deduction and induction to work together and find the physical landscape and the modeling process. The two directions representate the rationalism and empiricism respectively. For the personal feeling during the modeling, simple model, complex system. The modeling taught me how to simplify the complex outside the world, applying simple and natural laws. The modeling enlightened me to hold the certainty in the randomness, accept the fluctuation in the certain track, and find the infinity within the limitation. These experiences made me see the big picture and know every life are equal, getting along well with the deficiency in a peaceful mind. Last but not least, I would like to thank all the colleagues and the teammates that contributed to this achievement, who continuing their academic endeavor at the world top institutes and groups. Since 2013, the conference at Toulouse, the International Society of Ecological Modeling, gave me many opportunities to fast growing in the field, and I would like to commit myself in the future career to this community. The 5 paintings by the Dutch artist Vincent van Gogh was used to inspire the audience in a combination of art and science. Thanks for your attention and kindly circulating this video if you like. Hope it helped and inspire more people. Please find me at ResearchGate, Google Scholar, LinkedIn, Facebook, and Twitter at Joey Zhu Yuan Li.